Welcome to the Software Workshop with Paragon 11.3.11. You probably know that there's two ways to code the robot, blocks programming and Java with Android Studio. A lot of teams choose Java, and if your team is one of them, you'll realize that not only will you need to be familiar with the public FTC SDK, you'll also find Git version control and debugging methods to be very important. This is why in this workshop, we'll be talking about Git version control and debugging tools and skills. First, I'll be talking about version control. Version control is important in team settings like robotics because it allows you to collaborate with teammates, view and revert to previous iterations of code, and a backup copy of the code can be saved on a server to prevent data loss. First, let's understand how a version control works. There is something called a repository or repo that is stored in the central server computer, usually GitHub. Git involves a remote and centralized repo and local repos, which are stored on the computers. This means that it follows a distributed version control architecture. For you, that means that when you get a copy of the repository from the remote, it includes all of the change history. You will work on your code on the local machine, commit it to a local repository, and then push it to the remote so that everyone else can see your changes. To get ready to use Git, you will need to install Git and set up a GitHub account if you haven't already. To install Git, follow the instructions for your respective device, and follow GitHub's instructions to set up your account. This is a basic usage of version control. First, to set up, you'll need a repo to work on. You can create your own repo, but for FTC purposes, you only need to fork from the FTC SDK. The link is in yellow. This copies the SDK repo into a repository that you have full control to. Then you clone to copy that repository from the remote to your local computer. After that, you enter a cycle of adding features and fixing bugs. For each change you make, you'll need to run the Git commands in white to update your changes so that the team can see and the server can have a backup of your code. Git adds stages of local change to the local repository. Git commit saves your changes to the local repository with a description. Git push sends your local changes to the remote repository. And once that's done, your teammates can use git pull to get changes from the remote repository to their local repository. You should also run git pull from time to time to make sure that your code is updated. During the cycle, you can run these additional commands in pink to review the state of your local changes and change history. Git status tells you the files that have been modified, staged for commit, or have a conflict. Git diff checks the changes in the file content, and log shows the commit logs. Now I'll be demonstrating the basic usage of Git. Okay, so in this demo, I'm going to show you how to set up your repo and do all of these things here. So first, we're going to fork the repo from the FTC SDK. The fork is right up here, and when you use the dropdown, you can create a new fork. Yes. And then once you create the fork, we're gonna wait for it to, yes. Okay, now we have a fork. Now we have a repo. Now you have a repo that you completely own. That's a copy of the FTC robot controller. So what you can do now is you can now clone the code. So you can clone the repository. So to do this, we'll copy the link that is under this drop-down menu, and then we'll go to Android Studio to create a clone. So let me pull up Android Studio. And on Android Studio, you're gonna see that you can do get from VCS. When you tap that, you enter the URL and press clone. Oh, just like patiently waiting. Right now, cloning is in progress. It's taking. Okay. Well, it's finished cloning and it's opened up a new window, which is this. So right here, you have the FTC SDK. I won't go over into detail, but essentially, once the directory loads, you're going to be writing all of your code here. The directory is taking a really long time to load. This should show a menu of like all the files and folders. Seems to not be loading. Guess we'll just give it a minute and the editor will drop it out, I guess. Okay, this is now the fully loaded version of the FTC SDK. So you're gonna go to team code, and that's where you're gonna put like all of your code. So my video got cut off here, but this is how you create a new file in Android Studio. Okay, well now you have something great. So we're gonna navigate to terminal, and in a terminal, I'm gonna show you how to add the file for how to like go through the process of pushing this file to the remote. So we're gonna start with git status. As you can see, it shows you the changes to be committed and changes not saved for commit. So I already added the new file since like the pop-up did it for me. But basically, this now told the version control that we've added a new file, and that file is going to be part of version control. And I've also modified the code in here, so that's why we have this. And in order to add the code, we just copy its directory and we do git add, paste it. Now if we do git status again, it says that this is a change to be committed and no changes are not staged for commit, which is good for us. Now we can do git commit, and it will prompt us to enter a message. So we can describe the changes that we made. To do this, you press I, and then you can type in something. Added a file. Then you press escape, :write, W for write and Q for quit, and then you've created your commit. Now use git push to push your code to the remote. And it's done. Now we can go back to our repository and repository. Then if we reload, you'll see that this branch is one commit ahead of the FTC SDK. And the change is that I've added a file. So yeah, this is me adding a file. And then let's say that, and then since I was the one that made the file, git pull wouldn't really work since you wouldn't see it work, but if you do git pull, it will give you some warnings, and then it'll either pull the code or it'll say already up to date, which is the case for me. Let me also show you what git log and git diff does. So git log logs like all of your files in like this. And then you can press enter to see all of the changes. Now this is getting to like the actual FTC SDK. We'll do Q and then it quits and we're out. Then, and then I'll show you what git diff does. So like if I add a comment, whoops. This will basically show in green that I've added a comment here. Yeah. Then you do Q to exit again. If you add or remove files in your project, you'll need to let version control know about it. To add a new file, create a new file on Android Studio and use git add to add it to version control. To remove a file, use git rm file name to remove it from the repository. And to rename a file, use git mv old name new name. MV is short for move, and this allows you to change the name of a file without losing its history. To move a file from one directory to the other, use git mv just like renaming, but instead of using names, you use a directory. A reminder is that all of these commands are equivalent to making changes to your files and then staging them. So if you need to commit to apply, the changes to the local repository and then push to apply them to the remote. Here are some other useful commands. If you've changed your mind about a change, you can unstage it for commit using git restore staged file, or you can undo your changes made to a local and revert it to a previous commit using git checkout file name. If you have a more urgent software task, use git stash and git stash pop to temporarily put aside your changes until you call git stash pop. This is shown in the diagram where there's a separate storage place for the stash, and then you can use it to stash your changes or to access the changes you stashed. Sometimes when pulling or pushing code, your changes may be on the same line as another change, which creates a merge conflict. Your git commands will fail if there's a merge conflict, and if you open the code, you'll either see these symbols with the less sign, equal to, and the greater than signs, or you can configure Android Studio to show a side-by-side comparison with all the changes and merge conflicts. Then you decide how to merge the changes and commit them with git add and git commit. Git log merge lists the commits that cause the merge conflict, and git merge abort undoes the merge and returns the file to the state before staging. These two might help you with the merge conflicts. So far, all of the version control we did is linear, going from one local change to one person to the next. One important feature of Git is branching, which allows you to diverge from the main line of work and collaborate on the branches before the code is merged to the main. In this diagram, a blue user created a branch off of the main branch, creating 3 versions before merging it. Meanwhile, the green branch is still updating, and some other person, who is orange, has created their own branch, and they also merged to the green branch. In this process, all of the people on everyone's branches are working in parallel. So unlike with linear version control, one person does not have to wait for another person to implement a change before implementing their own changes. To create a branch, use the command git branch name. Then use git checkout with the branch name to switch to that branch. To switch to the main branch will have the code name main. So if you want to switch to the main branch, use git checkout main. Then once you're satisfied with your changes, you can merge to a branch by first switching to the branch you want to merge to with git checkout main branch. Then you git merge with the branch name that you want to merge, and resolve any merge conflicts if they occur. You can also make a pull request once you've made a branch. And the pull request allows teammates to review and discuss changes between the start of a branch and the end of it before merging the branch. During this pull request, further commits can be added to the pull request. And once the teammates are finished discussing and the changes are approved, then the branch can be merged to the main line. Pull requests are done on the GitHub website. Once you've created a branch and pushed some versions to it, GitHub will show either that a branch was created and allow you to create a pull request, or you can manually go to compare changes and select the origin of your branch and the branch, then create a pull request. After that, you would invite other teammates to check your code, and what the other teammates would see and what you would also see is the differences between your code and between the branch and the origin of the branch. The teammates can also add comments to parts of the code. They can do it line by line, or they can add a general comment at the end of the review. There are 3 types of comments that they can make. There's a normal comment, and there's also a request change, which stops the requester from being able to merge it until the changes have been approved. And there's the approved comment. If changes are being requested, or if there are branch merge conflicts, then you won't be able to merge the branches together. But once everything is good to go, GitHub will allow you to merge the pull request, and you can close the pull request. This concludes my presentation on Git version control. Brayden will now talk about debugging.
Next section, debugging tools and tips. There are 3 basic steps in the process of debugging. First, we have to find out the particular areas where the bug could come from. Then we have to determine what is going on with the code in those areas. Finally, we have to find a way to fix the code so that it works as intended. This is a flowchart illustrating the basic process of debugging. Our first course of action is that we have to identify what kind of error we're working with. However, before we do anything with our code, we have to first check if anything external is impacting a robot. So we have to check if any parts are broken, if the battery on the robot is potentially too low, if any wires are disconnected, and if there's any connection errors, and we can also just try power cycling the robot to see if that will fix it. Once we've determined that nothing external is affecting the robot, then we can start looking through our code. And this is usually done with something called a log statement, which we'll talk about later. After we look through the code, we can find areas where the code isn't working as intended, and then we can fix them. However, sometimes if we can see that the code is working exactly as intended, then the error can lie in the logic of the code itself. In these scenarios, it's useful to draw out your thought process and identify why your current design may not be the best. After that, you can adjust your design slightly so the code will work as intended. Now let's talk about a few different ways to display information from your robot. The first way is telemetry statements. Telemetry statements are convenient because they are displayed directly onto your driver station. However, because of the limited space on your driver station, there is only a limited number of telemetry statements you can view at a time. Additionally, it will only display your latest data, and it won't show any previous data that it has displayed. When data changes quickly, it can be hard to get an exact reading of what your data is. Here are 2 telemetry statements along with their captions, which are shown here, and the value they are printing out. Always remember to include the line telemetry.update somewhere inside of your loop along with your telemetry statements so that the packet of telemetry statements will actually be sent over to the driver station. Logcat statements are very similar to telemetry statements, but instead of being shown on your driver station, they are shown in the logcat section of your Android Studio. These statements are usually made in the format log.verbose along with a tag and a message. Messages are displayed with a timestamp and along with their tag, and you can use the tag to filter through all of your logcat statements. Your logcat statements will be retained in your logcat section of your Android Studio even after your program is done running. So you can go through and look at your logcat statement history. Sometimes it's useful to store your logcat statements into another file. It's possible to do this by using ADB commands to write your logcat into a file. ADB stands for Android Debug Bridge, by the way, and it should come with your Android Studio. You might have to install it, but once you install it, you just have to specify the path to it. So what I did here is that I just typed in which ADB because I already had ADB installed, and then I found the directory it was in. After that, I just had to specify the path to it in my .zshrc shell, and then I was able to access ADB on my terminal. Keep in mind that .zshrc is mostly intended just for MacBook. So if you're using a different computer, there might be different methods that you have to use. After I was able to access my ADB, I just used the ADB command, ADB logcat, to write my logcat statement into a file called logcat.txt. And I was able to access this file both on my Finder and my Android Studio. The dashboard is a tool made by Acme Robotics that has a variety of features that help you monitor your robot while you run your programs. One of the features it has is field view, which allows you to view your robot as if it's currently running on a field. And more importantly, if you're running an autonomous program, it will display the path your robot is supposed to follow in green, and it will display the path your robot actually follows in blue. Another very cool feature of the dashboard is that you're allowed to adjust static and public variables directly on the dashboard without having to download your code. However, since you're not downloading it, after you make any changes to your variables, you're going to have to manually change your variables in Android Studio for it to actually be saved. A couple other features the dashboard includes is camera view, which allows you to view what your robot's camera is seeing as soon as it turns on. And an important distinction between this and camera stream is that the camera will remain on even after your robot starts to move. Graphing is also a feature that is included in the dashboard, where you can just graph different variables of a particular program. Because the dashboard is something that comes because the dashboard is a tool that is made by Acme Robotics and not something that comes by default, you're going to have to take some steps to set it up. All the information on how to set up the dashboard is found on the Roadrunner website. However, let's just quickly go over how to do it. It's pretty simple. So you just want to go to build.dependencies.gradle and copy paste these two lines in, one in your repositories and one in your dependencies. And then you can just put @config at the top of any program you want to be able to access on the dashboard. After that, you can visit one of these two websites depending on whether you use your phone or your control hub. And then after you visit the website, you should be able to access the dashboard, as long as you're connected to your robot. Finally, let's talk about some best practices when fixing bugs. When you are changing anything, any variables or functions in your code, always consider how your changes might affect other areas of your code. Additionally, when you're fixing code, try to keep the code simple, because simple code is always easier to debug. You should always make sure you understand what went wrong. Some bugs can take a while to figure out. So just identifying what happened, what was going wrong, where the error was, and how you fix the error can save you a lot of time in the future. The last thing you want to make sure you do is revalidate your code. So after you fix anything, test all major features of the robot to make sure that they still work. You never want to put in a fix that fixes one part, but at the cost of ruining another part. Thank you.